Alright, so charging problems can be something that a lot of people have difficulty with, myself included. In my opinion, it's a lot more difficult to visualize how electrons move down the wire, or how alternating or direct current works, and all that. It's a lot more difficult to visualize than, say, how a carburetor works or how, brake fluid flows through its system. In reality, it's only comprised of a couple components, and they will typically fail in predictable ways. You can, electricity will always surprise you, or at least it always surprised me, and you can get all kinds of weird things going on. But there are a number of good tests you can do to figure out why your bike isn't charging, if that is indeed the way that, if that is indeed your problem. Alright, now to orient you guys to how a basic charging system works on the motorcycle. What we have here is an exposed left side of the motor of a GS 450. And in here you see a couple of components. You see your rotor, and that has a couple of magnets in it. See that? There's magnets in here. And that thing spins around, and inside it you have your stator. And this is just a bunch of coils of copper wire in here. And it's electrical property that when you pass a magnet past a coil of wire, it's going to produce a burst of electricity. This comes in the form of AC, or alternating current. And that travels up, it goes through your regulator and rectifier, and into your battery, and that's the energy that charges your battery. Your battery works on direct current, or DC, and so it needs to be converted through the regulator rectifier. This is a typical regulator rectifier. In much older bikes, they were two different units, like bikes from the 70s, but from the 80s pretty much on, they look like this. What this does is at first it converts electricity from AC to DC so that the battery can get charged with it, and also it sort of caps off the voltage so it doesn't let the volts get above, say, 14.5 or 15 or whatever your bike has, so it doesn't blow up your battery. The reason that it's finned like this, you see it's got these cooling flares on it, is because it absorbs so much electricity. Your alternating current produced by your stator and your rotor, it caps off half of that electricity, and sometimes your stator and rotor will produce more than is required by the battery, and so it caps that off, and so it has to absorb all that, and it absorbs that through heat. And so these cooling flares allow it to cool down. Additionally, some of that heat is also absorbed by the stator and the rotor itself, and that's why when you take off your side cover, like I just showed you in the previous shot, you're going to get a bunch of oil bubbling out, and that's because the engine sends oil through there to help cool it down. So all these things, all this quote-unquote wasted electricity is absorbed in heat, and it's dissipated by your bike. This is why it's so important that, let's say you're rerouting, electrical components in your bike, and you want to move all this junk, somewhere else, It's important that you have all of this exposed to good airflow. Otherwise, it will overheat and fail, and maybe cause other components to fail. So when we're diagnosing charging issues, there's two really important notions that you all have to remember. The first is that the vast majority of charging problems, regardless of what part has failed or what's going on, the vast majority are caused by corrosions at connections. This leads into the second notion, and that is that rarely does just one component fail on its own. Typically, it's sort of a cascade of things. Something has caused something else to fail. A burnt out wire has failed, and so that it has caused your regulator rectifier to overheat. Or your regulator rectifier has failed, and that has caused your battery to fail. Something like that. So if you just identify one thing in your charging system that has failed, it's always a really good idea for you to for you to check out the entire system, because whatever you replace is likely to burn out again or to fail again if you don't find the root cause of the problem. Alright, so now we're going to check that there actually is a charging problem. Just because your battery is discharging doesn't mean that there's necessarily a problem with your charging system. You could have a parasitic draw, which is when your battery is wore down even when the bike is off. That could come from really anywhere in your electrical system. We're not going to really talk about it in this video because it's a totally different thing. However, this is how you check your charging system. Go ahead and get your volt reading of your battery. 12.6, that's great. You really want something like 12.4 to 12.8, somewhere in there. If it's low, if it's definitely below 12, then it's time for a new battery. So we're holding steady, 12.59, 12.6. And then what we're going to do is we're going to go ahead and start up the bike. And you can see even at idle, it's charging really well. Alright, now we're going to rev it up a bit. Alright, and that's just fine for this Honda. Some bikes are different. Smaller and older bikes actually won't charge while they're idling. They only charge like when you're riding the bike at a cruising speed, and that's normal for that bike. Some bikes, will actually step up a little bit. They'll charge it maybe 13 while you're idling, and then 14.5 while you're at cruising speed or whatever. Some bikes like this one charges just fine at idle. It all depends on the configuration of your bike. So that's normal for this bike. If you see a reading like, you start up the bike and the voltage drops, it goes down below 12, that's a problem. If you see that it fluctuates up and down, that's also a problem. But if you get, a fairly sustained high reading, above 13.5, 14 up there, then you know that your charging system's working pretty well. So what if it's not? Well, the biggest culprits are actually right in here. These, these nuts in here that connect the wires to the battery, they get hot and they get wet and they get corroded, and you get like all kinds of rust and corrosion and filth in here, and that robs your voltage. So the battery might be able to put out voltage, but it can't get recharged again, or whatever. So you take these apart, you clean them up with a little piece of sandpaper or a file, put them back together, and see if you are charging better. There are a number of other different connections. This is the positive, and it goes into your starter solenoid here. You can have corrosion here. You can have corrosion in the wires coming into the battery. You can have corrosion on your ground. That's another thing. Here's where it grounds right here. You take this nut off and make sure you don't have any rust or junk underneath there. Like I said in the beginning, corrosion in the wires are really the first thing that goes, and that's just the nature of the beast of our old bikes. We gotta constantly be aware of corrosion. That's why I keep all of my bikes covered under this tarp here, so that they don't get rained on. You really shouldn't ever let your bike get rained on, and this is why. So if you're not charging, that should be the very first thing that you go for, after you've confirmed that you have a good battery, of course. Alright, so now we're going to check our stator. You remember our stator from our Suzuki. You can do this with the case on and and all assembled on the bike. All you need access to are the 3 wires that come out of it. Typically they're yellow in Suzuki, sometimes they're different colors. You just want to locate the 3 output wires. So we're going to go to switch it to ohms and put it on our lowest setting, and then we're going to check between all 3 of these wires. And what we want to find is between 0.1 and 2 ohms. So that one's good. That one's good. That one's good. Alright, so it passes that test. Alright, so next test we're going to do of this stator is to make sure that it's not shorting out to the case. To do that, again, you connect to a wire. You're in ohms still. Connect to a wire. And then if this thing is still on your bike, just go ahead and touch it to the outside of the engine case. See that? Nothing. That's good. Nothing. Good. That means that this is most likely a good stator. It's not shorting out to the case, and it has good resistance through its wires. Now we're testing another stator. This one I have the red hooked up to one of the yellow wires, and I'm going to just touch the case. Uh-oh. This one is just starting to go. See, I'm getting like 1.2 ohms there. That means it's just starting to short out to the case. So that's what you don't want. Now if you're very lucky, you can find a regulator rectifier test chart in your repair manual. Another great reason why it's good to have a repair manual for your bike. You don't have to listen to anything that I say, you can just look it up. So if you have one of the rare rectifiers, regular rectifiers that can be tested, you just look in here and you can see what the ohms should read. Like, let's say you put it up to the yellow and the red, and it should be 2.5 to 3.8, and you can check all this stuff. I'm not going to demonstrate it because it's pretty straightforward, but another great reason to have a repair manual. So yet another test that we can do is to test the output of the stator. For this bike, I know that I should have about 75 volts alternating current coming out of my stator. Remember, this is before the electricity reaches the regulator rectifier, so it's still going to be an alternating current, and it's still going to be a ton of volts, way more than the 12 volts that the battery wants. So what I'm going to do is I'm going to disconnect my 3 wires coming from my stator. Got my altimeter here on alternating current volts. The black is going to get grounded, and I'm going to check 1, 2, and 3. 1, 2, and 3 while the bike is running. It's important that they're all the same, and it's important that obviously they're all up at 75. So now we're going to check it out. Alright, so now we're going to start it up, and we're going to crank it up to maybe 5,000 RPMs or so. Alright, so you saw the first one wasn't producing shit, and the second 2 were pretty low. That all indicates to me a problem. So either it's a stator or a rotor or both or whatever. If you get readouts like that, that definitely shows a defective charging system. Alright, so you've tested your rotor and stator, you've tested your regulator rectifier if you're able to. You've checked all your connections. If you haven't found any problems in there, then really the very last thing is your battery. Sometimes a battery will read good volts, but it's corroded inside or old, and it just doesn't produce the amps or whatever. Maybe your battery's low in fluid or whatever. All kinds of maladies can plague a battery. Just throw another one in there and see if it can hold a charge. It's kind of frustrating to have to tell you guys, go buy a new part and see if it works, but sometimes that's the best you can do. So suppose you've found a problem, something is out of whack with its continuity, like I just demonstrated on this bike, or you've got, bad output from your stator or whatever, how do you fix it? Basically you're just gonna go ahead and replace the part. eBay is a great source for good used motorcycle parts. It's always a good idea to ask the seller, like, oh, was this on a running bike? Was it charging well? How long has it been sitting? How long ago did you remove it? Da da da. Just to make sure that you don't accidentally buy another defective part. Some people have had luck putting in non-OEM parts. A YouTube fan just wrote me in and showed me the regulator that he installed on his bike. And that's cool or whatever. If it works, then hell, go ahead and do it, give it a shot. The worst thing you're going to do is burn out your stator or whatever, but you can always buy another one of those. I'd probably be a little bit more reluctant to do these kinds of, swap them out experiments on bikes that are a little bit rarer. But, anything from the CB line, GS line, KZ line or whatever, there's tons of parts out there. Go on the forums, go on eBay or whatever. So, if you want to go on down to Radio Shack and buy a $4 regulator like he did, then sure, why not? Go for it. Tell me how it works out for you. Finally, remember what I said about rarely do things fail independently. If you've got a bad regulator, it can take out your stator. If you've got corroded wires, it can, take out your battery. If you're constantly asking more and more voltage from your battery without putting that voltage back into it, then you are going to burn it out. A battery is actually a pretty hardy thing. It can, even if you're not charging at all, you can probably run your bike for an hour or even more just on the battery life alone. And then if you fix your charging system, you charge your battery back up and it's usually pretty good to go. However, if this is a chronic thing, it can, burn out your battery. It can burn out other parts of your bike. If your regulator is not working right and it's sending 75 volts of AC current directly into your battery, well, your battery is going to fucking explode. You might fry wires, you might do all kinds of stuff. So, as you can see, there's really only a couple of things in here, maybe you got a couple of fuses and connections or whatever, and that's basically it. But it's actually pretty important that you guys, take a good look at it all and give a good assessment. So if y'all have any questions, let me know. I'm sure there are charging systems out there that I haven't covered. This was just a really rudimentary thing. But, if you have any questions, I'll try and help you out with it. All right, good luck.